Hello everybody. So, I'm gonna do this screencast thing one more time. For my screencast, or lesson plan, I was given statistics and probability, and now before you all moan and groan at me, we are gonna take it back a little easier than college level, and we're gonna go back to 8th grade statistics and probability. So what does this all entail? Well, statistics and probability for 8th graders has to deal a lot with scatter plots and lines of best fit and interpreting what those mean. So what we're going to focus on today are those three things, but really emphasizing on the last one of what they mean and what you can determine from a line of best fit or from a scatter plot. Okay. Let's bring it back to the basics a little bit. What is a scatter plot? So a scatter plot is simply just a graph with the dotted data points that has been collected from a so-called experiment. For example, let's say in science class you want to know how long it takes for a tennis ball to drop to the ground, and then from different points, or height points, I mean. So the way you do this is you do the trial several times, and you raise that height a little bit more and more, and you get to see the relationship between the two, the height and the time. Which leads me into my next point, is why do we use scatter points? And we use them to determine how much one variable is affected by another. And the reason that a scatter plot is what it is because not everything follows in a linear form or in a form that goes into an equation. Sometimes it's completely obscure, and so we kind of have to figure out an equation that would best represent the data, which leads me to my next point of basics, but what a line of best fit. Now, what is a line of best fit? And it's a straight line that best represents the data on the scatter plot, and the line of best fit can pass through some of the points, none of the points, or all of the points. And the first thing to determine when we're looking at a line of best fit is to look at the correlation of the scatter plot. So is there a positive correlation, a negative correlation, or no correlation at all? And by this I mean with positive, it means that your x variable is increasing as your y variable is increasing, and then the negative correlation is when your y variable is decreasing but your x variable is increasing. And then if you have no correlation, it means that you just have a plot of points, and they're not going any which way. It's just kind of like polka dots. It's fine. Okay. So, how do we find a line of best fit? Great question. A lot of way the teachers do this is they will give students a spaghetti noodle because it's A, transparent, and B, straight if you're using a dry one, which is what they do. And then they can use a spaghetti stick to play around with it to try and get it to fit the points in the best way, and then draw a straight line from that. And then that there is the definition of a line of best fit. And then to determine the equation of that line of best fit, you can use the following equations on the screen, which you first want to find the slope, which is subtracting the y1 from the y2 point and dividing that by the x2 minus x1. And then you use that slope and you use the y1 and x1 and plug it into the y minus y1 equals m times x minus x1, and then there you go. You can simplify it around if you like. Alright. So, now that we've gone through the basics, this next one might be a little new to some of you guys. I know it was for me. Or not, some of you may be really smart, which we usually are. But that is, my next point is what I'm trying to get to is what's a median line. And a median, oh look, I made a typo. Look at that, folks. Alright. So a median line is just kind of a more precise way of finding a line of best fit. It does, so because it is more precise, there is more work behind it, but I'm at a college level, I think that we can handle it. So let's get started on how to find this median line. So as step number 1 says, you're going to take the groups and you're going to separate them into 3 equal groups. Not the groups, you're going to take this set of data and split it up into the equal groups. It's easiest just to deal with the x values because then you're not confusing yourself or making an oops or something like that. But they separate into 3 equal groups. Obviously, not everything is going to be divisible by 3. So in the case that your set of data is not divisible by 3, you're going to make sure that the first group and the last group, so your lowest values and your highest values, are equal. So if you have a 4 and a 3 and a 4, that's what you want to have. And then you can move on to step number 2, and in that special case, let me backtrack for a second, is if you do not have 3 or a group of data that's divisible by 3. So the second case is finding the summary point of each group, which is done by finding the median of the x and y coordinate. And then once you've found those medians, find the slope using the medians found, but only from group 1 and 3. So the first group and the third group, which is why it's so important that they have the same amount of x values in them. Now that we've found the slope, we're going to move on to find that y-intercept. And to do this, you're going to add the 3 y medians, all 3 of them, that are correlated with the x medians that you found. And then you add the 3 x medians. And now that you have those 2 separate sums, you can subtract the y, or the x from the y, and then divide that by 3. And that there, folks, is your y-intercept. Okay, so now you're probably wondering, okay, so now she's babbled on about line of best fits and scatter plots. How does this relate to technology? Because obviously we're in a technology class. Well, another great question. Thanks. The way we're going to do this is by using Desmos. Remember that thing that we used to make those rainbows in the beginning of the semester? Yeah, we're going to go back to that one. So if you want to go ahead and open Desmos, and maybe pause the screencast, and we'll resume in a sec. Okay, so hopefully now you've all made it to Desmos, and you have to click Start Graphing, so this is a screen after it. But the way that we can do this is sometimes with our pencil and paper drawing of scatter plots and lines of best fit, it's not always great because let's face it, not all of us are the greatest drawers. And also there's human error in there. So the way we can check this is by plugging it into the computer. So if we go to Desmos.com and then you go up to this little plus button right here and click, then you go down to the third function, the table function, and go ahead and click one more time, and it brings you up a table. So the nice thing about this is that it's going to allow you to plot some points, and then it'll show you the graph over on the right side. So let's just pick some random points. Let's say 3, 5, 4, 6, 2, 3. Oh, don't want to go there. 1, 4, and you can see that as I'm plugging in these points, they are appearing to the right side of the screen, so you can see them pop up. Okay. Oh, can't see that. There we go. Okay, so the nice thing about this, like I said, is that you can see them all pop up there to the screen on the right side. And then from here, what you can do is once you've found that line, now I didn't find the line of these data points, unfortunately, because I just randomly made these up. You can graph the line to see if it works with your data. I mean, if I were to make up a line, I guess I would go with y equals, oh, I don't know, x plus 2.2. Something like that. Pretty close. and then you can see, you know, is it working or not. And the nice thing about Desmos is that you can click and disappear your points if you'd like. Okay, so now that we've gone through it all, bring this worksheet with you to class. I hope you downloaded it. I guess I should have said that in the beginning. Oops. Bring the worksheet with you to class because it will help you with the things that we are doing tomorrow, okay? Have a great night, and I will see you soon. This is Anna, over and out.